Welcome to Flawless Mathematics. Hello everyone. Today I will discuss some systems of derivative, which is also very important to do any kind of math of differentiation or as well as integration, right? So our first system is number 1 is chain rule. Okay, chain rule. So what is it? Chain rule. First of all, where can we apply chain rule? So derivative of function, right? Derivative of function with the help of chain rule. Okay. So what is the application of chain rule? Derivative of function with the help of chain rule, right? Now that means y equals to, if can we write it and mathematical form, right? So y equals to, let's say, f of g of x, right? F of g of x. Now if we want to derivative this y, here we can apply chain rule. So let g of x equals to u, okay, or u equals to g of x. Now if you derivative both sides with respect to x, now what can we get here? Du by dx equals to ddx of g of x, right? ddx of g of x. That means du by dx equals to g dash x. Okay, in another word we can write it ddx of g of x as g dash x or g prime x, you can say. Okay, now here y equals to f of u, because we assume that g of x equals to u, so y equals to f of u, right? So now if we derivative both sides with respect to u, then what can we get here? dy by du equals to f dash u, right? F dash u. Now if you put the number, this equation 1 and this equation as 2, now 2 into 1, if you multiply these two equation, then what can we write here? dy by du into du by dx equals to f dash u into g dash x, right? G dash x. Okay, see here du by dx equals to g dash x, and here dy by du equals to f dash u. So here dy by du into du by dx equals to f dash u into g dash x, right? So now you can see du and du both are cancelled over. Okay, so finally we get the equation dy by dx equals to f dash u. What is u here? G of x. F dash g of x into g dash x. And that's the formula of chain rule, right? That's the formula of chain rule. So let's summarize it. If there is any function of function and we can derivative of that function, let's say y equals to f of g of x, then the formula of that derivative is dy by dx equals to f dash g of x into g dash x, right? Now the second system. Now our second system is derivative of parametric function. So first of all, we have to know that what is parametric function. So if we express x and y with a parameter, okay, let's say for an example, if you take a circle, now the parametric form of circle is x equals to a sin theta and y equals to a cos theta. So there theta is a parameter, তাই তো? তাহলে কি হচ্ছে দেখো, তাহলে y equals to, আমরা যদি এরকম ভাবে ধরে নিই, let we assume that y equals to f of t and x equals to g of t. So here t is a parameter. Okay, That means if we express x and y with respect to a parameter, then we can say here that the function is a parametric function. Okay, so if we want to derivative of a parametric function, now what formula and what system we apply here, right? So first of all, we have to derivative y and x respectively with respect to t. Okay, so let's do dy by dx equals to, here we write f dash t. Okay, because ddx of with respect to t, that means dy by dt equals to f dash t, because ddt of f of t we can express it as f dash t, right? And here also dx by dt equals to g dash t, right, or g prime t. So dx by dt equals to g prime t. Now our target is to derive dy by dx, right? So how can we get here dy by dx? If you think that dy by dt divided by dx by dt, then you can see that you can get dy by dx, right? পাচ্ছি তো, তাহলে dy by dt divided by dx by dt তে আমরা কি পাচ্ছি dy by dx, তাহলে এখানেই আমরা বসিয়ে দিচ্ছি। ওকে, now we apply now we put dy by dt and dx by dt. Okay, so what can we get dy by dt as f dash t and it also g dash t, right? And remember one thing you have to remember here, that g dash t not equals to 0, g dash t not equals to 0, and that is our formula. Okay, so derivative of parametric function. Now our system third system is derivative of implicit function. Now what is implicit function? So implicit function is in the form of the function f of x comma y equals to any constant term. Okay, that means if there is an expression with implicitly or indirectly, here you can see that if there is any equation that is x square plus y square equals to 25, so that type of function we can call it implicit function. And another one is explicit function. So if there is expression with y square, that means 25 minus x square root under, okay, plus minus, so that is explicit function. So when the expression of a function is with indirectly or from indirectly or implicitly, then we can call it as implicit function. Now the general form of implicit function is f of x comma y equals to c. Okay, get it? Now how can we derive the derivative of implicit function? So let's take an example. Okay, we will go through the derivative of implicit function with an example. So let's say our example x square plus y square plus xy plus x plus y plus 2 equals to 0. Okay, so how can we derive its derivative? So first of all, we have to derivative with respect to ddx. Okay, that means with respect to x, that means ddx of this whole function. Okay, so that means x square plus y square plus xy plus x plus y plus 2 equals to 0. Okay, or so derivative of x square is 2x and derivative of 2y, here the function is y square, so we have to do here 2y first, okay, and into dy by dx. Okay, into dy by dx. Why? Because here the function is of function of y, right? So first of all we assume that y equals to, here also we can apply the chain rule. So first of all we have to assume that y as x, that means the formula of x square is 2x, so here 2y into, therefore the derivative of y, so dy by dx, right? Plus here the fundamental rule, when we have discussed the fundamental rules of derivative, there the rule is u into v form. Okay, so first of all we have one constant, one treated as constant, so x, and then another functions of derivative of another function, that means x into dy by dx plus y into derivative of ddx of x, that means 1. Okay, plus here also ddx of x, that means 1, plus here y, that means dy by dx, and plus derivative of any constant term, the formula is any constant term, that is 0, right? So equals to 0. Now here we separate from dy by dx, that term. Now if we separate that term, then what can we get here? 2y plus x plus 1 into dy by dx, and another term is minus 2x minus y minus 1. That means dy by dx equals to, if you take minus at outside, then 2x plus y plus 1 divided by 2y plus x plus 1, and that is the answer. Okay, so this is the approach how can we derive of derivative of implicit function, right? So now our next system is derivative of a function with respect to another function. So as much this system, before this system we have already discussed with respect to x. Okay, now how can we derive the derivative of a function with respect to another function? That means if you take an example, that means derivative of f of x with respect to g of x, right? This kind of problem, how can we approach? Okay, so first of all we have to assume u f of x. Let assume f of x as u. Now du by dx, what can we get here? F dash x, right? And v also g of x as v. Now dv by dx equals to g dash x. মানে হচ্ছে যে দুটো যে ফাংশন রয়েছে সেই ফাংশনগুলোকে আমরা একটা একটা করে একটা u একটা v আমরা অ্যাজিউম করব। ওকে, so that means we have to assume the function, both function f of x and g of x. So here we assume f of x as u and g of x as v, and then we have to derivative both side with respect to x, right? So now here the question is derivative of function f of x with respect to g of x. That means d divided by d here with respect to g of x, that means v, right? So v, and derivative of f of x, that means u. Now du by dv. Okay, so du by dv, du by dx divided by dv by dx, okay, equals to here f dash x divided by g dash x. So it is a similar with the parametric form also, right? So here also you have to remember one thing, that is g dash x not equal to 0. Okay, so that's all for today, and in next class we will discuss the derivative of logarithm function, derivative of exponent function, and etc. Right? So up to the derivative of production function, derivative of quotient function, derivative of infinite function, etc. Okay, so up to this, that's all for today. Okay, bye bye.